We have a jet is flying through a wind that is blowing with a speed of 55 miles an hour in the direction north 30 degrees east. The jet has a speed of 765 miles per hour relative to the air, and the pilot heads in the direction north 45 degrees east. Express the velocity of the wind as a vector in component form. Okay. Draw myself a nice little picture here. A jet is flying through a wind. The wind is 55 miles an hour in the direction of north 30 degrees east. So where's north 30 degrees east? It's this one, where this angle right here is 30 degrees. So what angle do we use? 60. We use 60 degrees. All right, so the wind is, well, it's 55. And then how do I find the I value again? I take the speed and I multiply it by cosine of the angle. So it's going to be 55 cosine 60 degrees I plus 55 sine 60 degrees J. So that's cosine of 60 degrees is 1/2. So that's 55 over 2 I plus sine of 60 degrees is, so it's going to be 55 square root of 3 over 2 J. Alright, so there's the wind. Part B, express the velocity of the jet as a vector in component form. Well, the jet's in a way a little bit easier because the jet's going this way at 765 miles an hour, and his angle is north 45 degrees east. So his angle is 45 degrees like that. So what angle would we use? 45 degrees still, but we would actually measure it this way. That doesn't change anything. So the jet is 765 cosine 45 degrees I plus 765 sine 45 degrees J. So the jet is 765 cosine of 45 square root of 2 over 2 I plus 765 square root of 2 over 2 J. Part C. Determine the true velocity of the jet as a vector. You'd add them together. So you'd have the jet propulsion, how it's pushing it, and how the wind is pushing it. So, not a very nice answer, but here it is. Wind plus jet. It's 55 plus 765 square root of 2 all over 2 I plus 55 square root of 3 plus 765 square root of 2 all over 2 J. I would be thrilled if you gave me that as an answer. I would also accept, I think at this point it would probably be reasonable to type those fractions into our calculators and get some decimals. So let's do that. Let's get some decimals. So grab your calculator, type in 55 plus 765 square root of 2, and then divide that whole answer by 2, and tell me what the answer is. 568.44 I plus, and then do the other one too, please. 88.57J. Okay, good. Part C. Oh, we did part C. Determine the true velocity. We did it. There it is. Part D. Determine the speed and direction of the jet. How do we find the speed? How fast is this jet really going? It is the magnitude. How do you find the magnitude? All right, so the speed, ran out of room. Speed is the square root of the x component squared, 568.44 squared, plus the y component squared, 588.57 squared. So again, you grab your calculator, you punch a bunch of buttons, and you tell me Bless you. $818.25 miles per hour. No, that's only the speed. To find the direction, we use tangent theta is y over x. So that's going to be 588.57 divided by 568.44. And then we do tangent inverse. So again, you can punch the buttons. .99 degrees. Are those answers believable? 818.25 miles an hour. Is that a reasonable answer? Is it a reasonable answer for this jet plane? Well, look at the picture. Think about what's happening. The plane is flying at 765 miles per hour all by itself. The wind is mostly behind it, isn't it? So the wind should be speeding it up. If the wind were going the other way, we would expect an answer smaller than 765. If I were to take 765 and add 55, I would end up with 820. So it certainly has to be somewhere between 765 and 820. If the wind were exactly behind it, it would be going 820. So 818 is a reasonable answer. And 45.99, well, the plane's going 45 all by itself. Is the wind pushing it a little bit higher? Yeah, a little bit. So 45.99 is a reasonable answer. Well, that's something to check on when you get these answers. Do they make sense? And I think in this case, both those answers are reasonable. Oh, great question. Should I give it in pilot form? All right, so in pilot form, that would be north and east. And it would be 90 minus this angle, wouldn't it? 90 minus 45.99? 44.01? On a quiz or a test, I truthfully wouldn't care how you gave the answer. But if you're doing your homework on MyLab, or not MyLab, you guys use WebAssign. If you're doing your homework on WebAssign, check the directions, see how they want the answer written. If you gave me this answer, I'd be perfectly happy.
What would they call it?
They would call it the bearing. They would say, give the bearing. And written in this form, this is called the bearing. Questions on that?